Okay, hello folks. So, in lieu of class today, I'm going through the old test, the test that we just had. Test number 1. Turn 1, sodium sulfite. What is the chemical formula of sodium sulfite? So sodium, if you haven't figured it out, is Na. It's group 1, meaning it's 1 plus. Sulfite. The ITE ending suggests the lower amount of oxygen. So sulfate is SO4, 2 minus. So sulfite is SO3, 2 minus. Finally, putting those two concepts together, taking the 1 and the 2 and crossing them to neutralize. Neutral compound, so we need 2 sodiums. Or D. Question number 2. What phrase or term would describe a mixture that is not uniform in composition, like oil and water? So non-uniform would be, instead of the same throughout, we have different throughout, or heterogeneous. We have a mixture of water with oil floating on the surface. This one, you had to read this correctly, and you had to read it to the correct number of places. So if this is 20 and that is 30, that line right there is 25. So meaning the meniscus is right there on 24. However, to do this correctly, you have to read it to the estimation place, which means we have to eyeball it. There is no markings for tenths of a milliliter, so we have to estimate it. Any number that got me somewhere like 24.0 or rounded to 24.0 would be correct. Now, this one, critical thinking says the answer has to be B, but how do we get it mathematically? That if Fe is 69.9, essentially 70% of iron oxide, and I have 293 grams of iron oxide, how much would it be? So our thing is percent equals mass iron over mass total times 100. So you would have had 70 equals X over 293 grams times multiplied by 100. Rearranging that, so you have 70 times 293 divided by 100, and you would have got 205 or something thereabouts. Vacuum of space, 3 Kelvin. So turn this into Fahrenheit. 2-step process. First step, Kelvin to Celsius. 3 Kelvin minus 273 equals, we have negative 270 degrees Celsius. Now the next step is to turn this into Fahrenheit. You're going to take 9 over 5 times Celsius plus 32. So you take 9 over 5 times a negative 270, and then you take that answer and you add a 32 onto that, so you get an answer that should be negative 454. Now, moving right on, the neutrons present. So if this is the total mass, we have to find out how many protons. Silver has 47. Silver has 47. Carbon has 6. Radium has 88. And argon has 18. So we're just subtracting them out. this one should be 108 minus 47 is 61. 14 minus 6 is 8. 226 minus 88 is, no. There's no reason why we cannot use our calculators. 138, and 40 minus 18 is just 22. Which statement about an atom is false? Atoms are mostly empty space? No, they are mostly empty space. The electron cloud is mostly empty, so that's a bad one. Electrons can be deflected by electrical fields. Yes, electrons and negative fields will repel, and positive fields attract. You read that through. Neutron was not the first subatomic particle discovered. Neutron was the last. You might be tricked with this one, but this is clearly the better option. Electron is approximately 2,000 times lighter than a proton. You may have been iffy about the 2,000, but really this is the obvious answer. We discovered electron first, and then a proton. Okay, using the periodic table, predict the charge. So you look at what group it's in. 2A, 7A, 5A, 1A. Magnesium moves 2 to the left to get to 0. So it loses 2 electrons, make it 2 plus. Sodium moves 1 to the left, so it makes it 1 plus. Bromine, to get to 8, would have to move 1 to the right. And nitrogen, to get to 8, would have to move 3 to the right. Last one on this page. What is the name of the following compound? NiO2. Remember, the number refers to the charge. So nickel is a transition metal. Oxygen is group 6, meaning 6A, meaning oxygen is typically 2 minus. So 2 oxygen 2 minuses means that nickel has to be 4 plus. O2 minus, so essentially if I draw those across, you'd have nickel 2 plus and oxygen 1 minus, but really we have to double those to nickel 4 plus and oxygen 2 minus. So the best answer is nickel 4 oxide. The nickel 4 refers to the charge of the nickel, not the number of atoms. Okay, naming these compounds. We have a transition metal guide. Titanium 4 oxide. Oxygen is group 6, so it's -2. Drawing these guys down, you would have had Ti2O4. Had you done that, I would have given you credit. But you should have simplified to TiO2. Now, hydrobromic acid. Bromic, so we have bromine. Bromine is group 7. It's typically 1 minus. So the hydro means it's just the hydrogen. So it would be HBr. Hydrobromic acid. Phosphoric, the IC acid tells me that this comes from phosphate. It comes from phosphate with a PO4 3 minus. So phosphoric comes from phosphate, so I need to add 3 hydrogens. 3 hydrogens to neutralize this. H3PO4. And this one, for shame if you got this wrong, especially because nitrogen trioxide, just read that, nitrogen and tri O3. Wikipedia wants to call it N2O3, but that's dinitrogen trioxide. That may be the common name, but that is not the IUPAC name, the way we are naming it. Now this one, if I have two isotopes, 79 and 81, right in the middle would be 80. If this is 79.9, it's right about at the middle. The key here is you got to read this dang thing. You got to think bromine 79 is significantly more abundant. I added in the significantly. Is 79 more abundant? Yes. Is it significantly more abundant? No. The abundance is closer to 5149. Is that a significant about? No. They are both about equally abundant. They're about the same. Because 79.9 is about the same. Okay, this next one is a math problem. You had to turn miles to meters and days to hours. Keep that in mind. First things first, we set up the ratio. 1560 miles over 184 days. So the first step is I'm going to turn miles to kilometers. 1 mile is 1.609 kilometers. And 1 kilometer is 1,000 meters. Then, so miles and miles cancel. Kilometers and kilometers cancel, and I'm left with units of meters. Next step is to convert days to hours. 1 day contains 24 hours. Day and day will cancel. So my math looks something like this. 1560 times 1.609 times 1,000 divided by 184 times 24. If I do this math and follow it through, solve this and then divide by the sum of the product of this, you should get 569. However, if you've ever seen the dang movie, you could probably eyeball it. They move a little bit faster than 10 meters an hour, but there's some stopping points. And they 136, they don't move more than 13 kilometers an hour. Frodo doesn't do a lot of running. If you said Legolas, maybe, but what are the names of the following compounds? Iron is a transition metal. So you could call it iron chloride, but you're losing clarity. To get full credit, or really any credit, you had to say chlorine is 1 minus, so this must be iron 2 chloride, because there is also a FeCl3 compound, which would be iron 3 chloride. So you have to differentiate. Now, magnesium is a standard group 2 metal. So we can just say magnesium oxide. Note, it is not manganese. Those are two completely different elements. Magnesium, Mg, versus manganese, Mn. Now the AQ tells you this is an acid. So just like HBr up there, this is hydrofluoric acid. And this guy is our nonmetal, so we just call this sulfur trichloride. Last page. This one may be harder than some of the others, but it was not meant to be. If you understood the concept, it's relatively easy. How many moles would be present in 250 grams of potassium carbonate? So 250 grams, we need to convert that. We're going to turn grams to moles, not to atoms, so that one's right out. So the first step is we need to find the molar mass of this whole compound. Now that's the weight of potassium, but there's two of them. We have carbon and we need 3 oxygens. If I remember right, this is something like 138 grams per mole. With that in mind, we set up 138 grams in 1 mole. And if you do that, 250 divided by 138 gives you close to 1.8. 250. Now this one, if you've ever had chemistry before, you maybe had a little cheat hint. Robert Boyle is known for Boyle's Law. I'm not expecting you to know that. I'll try to give you enough hints. Discover that volume of gas is indirectly proportional to pressure applied. So when you fill a balloon and you squeeze it down, it takes more force to compress it as it gets smaller and smaller. An observation without a proper explanation is a law. It is not predicting what will happen in future experiments. It is only saying when I squeeze something, as it gets smaller, it's taking more force. Not explaining why that happens, that the gas molecules are becoming more compressed together and thus they're generating a greater internal pressure, which means you have to have a stronger external pressure. There's no mathematical theory that's describing it. It's just a statement without an explanation. Observation without an explanation. Now this last one, almost identical to the old test. I've changed some numbers around. Don't just circle the answer to the last test. I'm not throwing an easy one if you listen to how we solved the last test, but I'm not throwing an easy one so easy that you can just circle the same answer. You have to read it. Based on the following data, what is the identity of the unknown solid? So we have a mass. So density is mass divided by volume. So 28.05 divided by 10.39. You do that math, you get a number that's close to 2.70. So it means our sample must be aluminum. Now the last thing, noble gas neon. Neon is group 8, meaning how many does it have to move to make it to 8? 0. Charge of 0. That is all.